Impact craters are found all over the Earth and even on the Moon. How did they get there? And what has that got to do with Noah's flood?
The impact craters on the Moon are arranged in such a way that it looks like there was just one brief period of impact bombardment. It affected the Moon, it affected the Earth, it affected other planets in the solar system, and it's part of the cataclysmic destruction at the time of Noah's flood.
Did an asteroid kill the dinosaurs?
No, it didn't. The dinosaurs would have gone on the Ark.
How did Noah's Ark survive meteor impacts which caused big tidal waves or tsunamis?
Well,
impact craters can be found all over the Earth and even on the Moon. So how did they get there? And what does that have to do with Noah's flood? Tas, you've studied geology for a long time. You've got a PhD and a earth science degree with first-class honours. Now, when I hear about the Moon, and well, not just the Moon, but asteroids and crater impacts, all of that, especially on the Earth as well, people often say that it points to a dinosaur extinction event, which happened millions of years ago. But you say that these craters on the Earth and on the Moon actually point to Noah's flood instead, which happened only thousands of years ago. Sounds like I've got a lot to talk about today.
We certainly have. And when they say it happened millions of years ago, it sounds like it's got nothing to do with us. It's just totally out of our league. It's interesting, but out of our league. But actually, impact craters have got a lot to do with us, and they change our way of thinking, impact our lives. There was a lady called Ruth Hamilton who lived in Golden in British Columbia in Canada, and she discovered that meteorites certainly were impactful on her life. She went to bed one night and was woken up in the middle of the night by her dog barking, and there was a crash on the roof, and she felt dust and stuff on her face. So when she put the light on, she found this great big rock on the pillow alongside of her, and she thought it had come from a explosion at a quarry or something nearby, but it turns out it was a meteorite that had come from outer space. And other people had seen meteorite showers in the area at the time. It was about the size of a cricket ball or a baseball, that sort of thing. And so she found that it was just as well it wasn't a big one like some of the ones we've had in the past. This was just a small one. And so meteorite impact craters impacts can be large and they can be small, and they are more closely associated with us than many people think.
Well, I can just imagine when she woke up and there's a meteorite on her bed, she probably thought she still had to wake up. She was probably still dreaming.
Yeah, still dreaming. That's right.
Hard to believe. Wow. Well, actually, we've got a bit of that on creation.com, don't we? There's an article on that.
We put an article about Ruth Hamilton on our website, and I think in the magazine as well. So it's a good story, isn't it?
Fantastic. Well, I'm sure our viewers can read that on creation.com if they're interested about that story a bit more. Now, you mentioned that there's craters that are, or meteorites that are smaller, but we have some very large ones and evidence of that too. Can you tell us a bit more about that?
Yes, you'd think that where are you going to find evidence for these large impacts on the Earth? You'd have to go somewhere on Earth to actually see them. But in actual fact, people can see them from wherever they are. And no matter where they live on the Earth, you can see the evidence of these enormous impacts. And it's not on the Earth, but it's on the Moon. So when you look up at a full moon, you can see these dark circular areas on the Moon. And originally, people thought that these were seas. They call them maria.
That's seas on the Moon.
Seas on the Moon. That's what the early astronomers thought. And they gave it that name because they're nice and smooth and they're dark. But in actual fact, there's been a change in thinking about these maria, about that they're actually impact craters, and which is quite amazing. So people can see this evidence just by looking up at a full moon and see the man on the moon, so to say.
Yeah, I can imagine how they, when you do see the moon, you see little hole shapes, and I've also heard, myths and stories about people thinking it was made of cheese. back in the day.
Yeah, well, that's a good one, isn't it? I guess cheese being yellow, if the moon gets down near the horizon, it starts to get a yellow colour compared with when it's up high overhead and so white and shiny. And I guess that has to do with the the way the light comes through the atmosphere, and it picks out certain rays of light, and certain other colours are emphasised, and that's why it looks that orange colour. But it's a nice colour, isn't it?
Yeah. Well, we certainly know a lot more about the moon now. So can you tell us, are those craters, are they definitely from meteorites? Can you be sure about that?
Well, originally people resisted the idea that they were for meteorites, and that came from geologists, because geologists had this philosophy, this culture where they would not talk about anything that was catastrophic, anything that happened quickly. Everything had to happen slowly and gradually. And also it had to be events which we could see on the Earth. And so they ruled out any possibility of things from outer space, out of this world. They ruled that out. And so they considered that these impacts on the moon were caused by volcanoes. That's what they claimed anything that was an impact crater. They gave it the term of a volcanic extrusion or something like that. But they've changed their mind since about the 1960s. The evidence is very strong and overwhelming. And so now they look at the impact craters on the moon and realise that these were caused by an impact of meteorites or an asteroid or something like that, something very large.
Okay, so they really have shifted their thinking. That there must be some sort of catastrophe, meteorite impact. Do you see, is it just one, or are there lots of craters? What's this, how many are there?
There are lots of them. If you go to Wikipedia and look it up, lunar craters, there's a whole list of them, gives their diameters and everything. Some of them are very large. You look at the ones that we can see on the moon would be, 300, 400, 600,000 kilometres across, some of those. So they are very, very large impact craters.
Yeah, so we've got a lot of impact craters on the moon, and we don't seem to see as many, well, I don't think we do on Earth. Why is there that difference?
You don't see a lot, do you, actually? On the moon, when you look at the moon, the surface is fairly pristine. You can see the crust of the moon. It doesn't have a lot of sediment which is covering it. Like the Earth has got kilometres and kilometres and kilometres of sediment over it. And of course, we look at that and see that it was deposited during Noah's flood. So that's what's on the Earth. And so any meteorite impacts which occurred and which struck into the sediment would then be buried by more sediment, and then that would be in turn covered by more, and then that would be eroded during the flood. So these processes on the Earth which would have impacted and would have affected the way in which we can see these impact craters.
Right, so that's why. So we still have some fairly big ones that we see evidence of today. So the really big ones that the flood couldn't completely wash away.
That's
but
right.
The smaller ones, a good portion of them, you're saying, could have been washed away, or are there other mechanisms that could have happened to cause that?
Yeah, that's right. So, and you sort of think about when they occurred, and you probably think about what happened on the moon first. The idea is these big asteroids struck the moon, and the surface of the moon is a crust, a hard crust, and it struck the moon and it pushed it in, it depressed it down, and so in doing that it cracked the crust, and the material inside the moon, it's a hot molten basalt, magma, and it came up through the crust, through the cracks, and it then filled up these meteorite impact basins. And so that's really, they're called lunar plains or something like that. So they're very smooth. And so that to me indicates that the lava that came out had to be very hot in order for it to be runny, and it had to be fill the crater quickly before it had a chance to cool and then not be able to run very much. If you go to places like Hawaii, where you see volcanic eruptions and you see these red hot rivers of lava flowing, and it doesn't go very far across the countryside before it starts to cool and build up into lumps and bumps and that sort of thing, and it becomes like, it looks like rope on the Earth. But you don't see that on the impact craters on the Moon. It's a nice smooth lava indicating it happened quickly and that it was very hot.
Right, so that rules out, volcanoes like we talked about on the Moon as well. It's the evidence that it's craters that have caused from a meteorite.
That's right.
Not volcanic flow from a
Not
volcano.
like a normal volcano that we see on the Earth. That's right.
Yeah. Now, talking about meteorite bombardments, do you think it all happened in one go or spread out over thousands of years in, I don't know, over the biblical history timeline? When do you think this all happened?
Well, the people that do a lot of the study on this and do a lot of the research are people who they don't believe in Noah's flood, and they believe it happened over millions of years. So they talk about the earliest bombardment on the Moon occurring, 4 billion years ago. And so they've spread these things over long periods of time. And the big bombardment of the large meteorites, they give that whole process a name. But again, that occurs over a period of, 500 million to 1 billion years that took to happen. But when you actually look at the meteorites, there's a really interesting thing about the way they're arranged on the Moon. Now, we can look at the Moon and we can see them, and they always face us. That side of the Moon always faces us, which is very interesting. And so people did not know what the other side of the Moon looked like, not until the advent of space travel, putting rockets in space and having rockets go out and going around the Moon and that sort of thing. And so they discovered that on the other side of the Moon, you don't have craters like that on the other side of the Moon. Maybe one or two, but not the great big clump of them that are on the side that faces us. Now, the Moon rotates on its axis. It rotates about once every 27 days, something like that. So if they're all on the one side of the Moon, you would think that they had to all happen at about the same time. You can't imagine a meteorite impact now, and then in 100,000 years' time, another one, and then another one much later on. And if it was just in random times like that, you'd expect them to be randomly distributed around the circumference of the Moon. But they're all on the one side, almost all on the one side. And so that gives an indication that all the impacts seem to have happened all at once. Certainly before the Moon went round a half a rotation, it might have even been in just a few days. And so that points to something happening very rapidly in our solar system and impacting the Moon.
Before we continue, a quick heads up. Stick around until the end of the interview because we'll be offering a free ebook, the Creation Answers book, which is packed with biblical answers to over 60 of the most asked questions about creation, evolution, and the Bible. You won't want to miss it. Now back to the interview. Well, that's very interesting, and I'm just trying to visualize this, and I've actually planned ahead here. I've got a little scale model Earth and Moon, and if you hold the Earth, I'll get
looks like an Earth. Well, it does sort of look like an Earth.
It's a very cheap. I made it out of tape, so it's not a very good quality Earth. But
I can see Australia. Yeah.
So if we hold it at the distance we are away, that's about how far away the Moon is to the Earth scaled.
Scale-wise, that looks about right. Yeah.
So do you want to describe how would have this meteorite shower happened, bombardment?
Well, which direction did it come in? For example, like it could have been coming towards the Moon from that way and facing towards the Earth, or it could have been going the other way, going this way, and it would have hit the Earth and the Moon, or it could have been coming sideways and sort of been more focused on the Moon than on the Earth, which is interesting because if you take the number of meteorite impacts on the Moon, and there are large ones and there are smaller ones, and you can see the large ones with your eye, of course, and the smaller ones, you may be able to see them, but they're quite sort of visible through binoculars. You can see the smaller ones, and certainly on an image on the Moon that you can download from the internet, you can see the smaller impacts on the Moon.
Yeah.
And so it all depends on which way the meteorite impacts came. The smaller impacts tend to be evenly distributed around the Moon, whereas the larger ones tend to be on the one side, which is very interesting. And they're now facing the Moon, they're now facing the Earth.
Right. So if the meteorites came from behind, so from behind you, okay, and they dodged your head, and then they hit the Earth, and then they sort of, gravity could slingshot them around a little bit, and they hit the side of the moon that's facing the Earth, and then it's already facing. But if they hit from the side or behind instead, how could the moon then, turn around? Because then it's facing the wrong way. The bigger Maria craters have got to face the Earth. How would that rotate around?
Well, so what we have is the impact craters occur. The lava, the magma from inside the moon, it comes out and sits outside now where it was inside before. So it's actually changed the angular inertia of the moon. And so you've now got where the center of gravity of the moon is no longer on the axis, but it's offset from the axis. And so it would have a natural tendency now with the gravity to sort of face the Earth. And so it's just the same way that the moon impacts the oceans and causes the oceans and causes the tide. So that would pull it around, and it's called tidally locked. The moon is tidally locked to the Earth, which is why it faces the Earth. That
makes sense. So whichever way the meteorites did come from,
it ends up being tidally locked.
Swings around because of gravity, and then we're facing it. Well, that makes a bit more sense. I've just got that in my mind now, being able to visualise it. Thanks, Tas.
Well, thanks for your model. That's great, Michael.
It's a bit of a cheap model, but we're a donation-run organisation, so we've got to do with what we've got. So
good on you.
But I think it works. So we're talking about the meteorite bombardment over a rotation period. It must have been during some time of the rotation period, not the whole time, not over the whole 27 days. So it's a fairly short amount of time. You said these are some problems for people who think meteorites would have hit over millions of years and gaps between them.
That's right. Over millions of years, you would expect the impact on the moon to be at random places around the circumference, not all on the one side. And so that indicates it happened quickly. It indicates also that the meteorites were coming from a similar direction. And you might call it a meteorite shower, but it's not really a good name. It's much bigger than that. It's a meteorite bombardment that impacted from the same direction on the moon. So there was something happening within the solar system that affected the moon and the Earth, and it's also affected the other planets as well. And you can do an estimate, like you look at what's on the moon, and it's easy to see what's there, and you can calculate what you would expect on the Earth, assuming, like, making allowance for the different size and the different gravity and that sort of thing. And a couple of scientists have estimated they're talking about 40,000 to 60,000 impacts on the Earth, which would have devastated the Earth, would have, smashed it to smithereens, but we don't see that. So there must be other reasons, from what their assumptions were about how the meteorite impacts occurred. And I think some of that has got to do, for example, with the angles of the orbits when it happened over a narrow time period, and also to do with the sediments that were deposited on the Earth, and so impacts which occurred which would be covered by sediment. And then there was the erosion as the floodwaters receded, so impact craters were eroded, and so some of them have been eroded away. So there's a lot of reasons why the number would be different. As I said, something like 190 is what's been counted so far, although there are still a lot that are being evaluated, and they've got fairly strict criteria before they enter it onto the database.
Right. Well, let's have a think about some of the craters we do see on Earth. And I've heard of, I think it's in South Africa, Vredefort. Am I saying that right?
It's Vredefort. It starts with a V, and it's called Vredefort. It's a big crater in South Africa. It's near Johannesburg, certainly within a few hundred kilometres of Johannesburg. And originally, geologists thought that this was a volcanic eruption which had caused it. And so that we get into that philosophy of thinking again, where you've got a whole sort of discipline of science where everybody's thinking the same way. Yeah. And so they don't see things that are there. And it took quite a while. South Africa was actually ahead of the pack, and they started to question that it was caused by a volcano, and they started to advocate a meteorite impact before it became more common in the rest of the world. But so Vredefort is one of the places, quite an amazing place. Did we talk about Sudbury, which is in Canada? That's another place where there's a big meteorite impact. And then there's, of course, the famous one, Chicxulub, which is in the Caribbean in there, the Yucatan Peninsula. And so that's another place where there's a big meteorite impact. So there's a number which have been claimed, identified on Earth, which are very interesting to look at those.
Right. So the Vredefort one, how long ago do secular geologists think that impacted the Earth? What's their view on it?
Well, they think it happened very early in geological history. And so they've produced a date of 2,000 million years, 2023 million years for the age of that crater. And so we can do a transformation of those dates. So when secular geologists come up with a date, we can there's a chart called the Geology Transformation Tool. We just look it up on the chart, the number 2023, and we see that it was very early in Noah's flood. And we can see that it was early because there's sediments in the area which had already been laid down before the impact occurred. So, but if you go to that area, it's Vredefort. It's the name of one of the towns in the area. And you look at the area, you go for a tour around and you can see these nice hills and that. You'd be flat out being able to recognize that it was an impact crater. And part of the reason is it was so big. You know, when you look at something really big and we're like little ants down on the Earth, and you look at it, you can't see it. You can see it though from a you can see it from a satellite picture of it, and hopefully somebody can get a picture of that and put it up here. It's quite impressive. And so that's the inner part of the crater. It's about 80 kilometres in diameter, and you can see this ring of hills that goes around, and which gives people alert to the fact that something's going on, and it suggested the idea of an impact crater. The other thing is you can see it from a geological map of the area, and so you can see that it's something circular, very interesting. And then when you trace it out and do the investigations, you can work out that it was an impact crater. So that's what the whole thinking has changed as a result of these things which have been discovered. Right.
And how big do they think, given the size of the crater, how big would that asteroid have been?
You can work it out from looking dynamics. You got physics and momentum and impacts, and you can work that sort of thing out by, the structure of the Earth and the strength of the Earth and that. So you can come up with some sort of an estimate. And they came up with an idea that the impact or the particular meteor was 10 kilometres in diameter.
Wow.
Doesn't sound much. How big's 10 kilometres?
Well, I think Mount Everest is almost that high. So I guess it's like a big Mount Everest rock.
It's the size of Mount Everest coming crashing into the Earth. That's right.
That's massive.
And so when you think about that, you think it's going to do things in a hurry, isn't it? It's not going to take a long time for this to happen. And so they've done a description of it. They've presented a scenario, a story as to how it happened. And so that when the meteorite hit that part of South Africa, there was already about 5 kilometres of sediment covering the area. There's a lot of volcanic sediment, and there's a lot of water-laid sediment covering this area, about something like 5 kilometres. And so, and underneath that was granite, sort of a volcanic rock, an igneous rock. It wasn't volcanic; it was igneous, and the sort of stuff that people put on bench tops in their kitchens and in their bathrooms. It's lovely granite. So that's a big area of granite, and then there's sediments on top of it, and the meteor strikes the top and it pushes the sediments down and it pushes the granite down. Have you ever seen a picture of a drop of water hitting a smooth surface of water? Have you ever seen that?
Yeah, and it sort of ripples come out and it
Well,
sort of splashes.
ripples come out, but what it does, it pushes the surface down and it forms this crater. You can see this little crater, it's about 2 or 3 times the diameter of the drop of water. And it just sits there for a while. And then the next thing, up comes water comes out, like a drop comes out, a spout of water comes out. And so that's what they're estimating happened when this meteor hit South Africa, that it went down into the earth and it went kilometers down. And then there was a rebound, which came kilometers up. And there was a lot of debris that was scattered over the whole area. And when it came up, it lifted up, the sediments were lifted up, and they formed like a collar around the granite which came up. And so that forms the hills. You see the hills, but it's only from the air that you can see that they're in this circle. And so it formed these hills. And in the sediments in these hills, it brought up sediments which had lots of gold in them. So there's going back 100 years, there were gold mines boring into these hills. And not only that, so it came up like that, and then it affected, like a ripple, it went out for tens, 20, 100 kilometres each way. And so the impact actually went as far as Johannesburg. And so it's enormous impact. And so it happened. How long would it take to happen for that to occur? You're talking about seconds, you're talking about minutes, you're not talking about days even, you're talking about a very short time. And it just gives an idea, if it happens quickly, it doesn't take long, and so you're not needing millions of years to form it. And so it's happened early in the flood, very early, and gives an idea for the sort of catastrophe connected with Noah's flood.
Hope you're enjoying the interview so far. We'll jump back in shortly, but real quick. Imagine bringing this life-changing message to your church or community. This is exactly what we do. We present at close to 1,000 events each year. So many people struggle with how science and the Bible fit together, and it becomes a genuine stumbling block for their faith. But our speakers present satisfying answers that really make sense. We've received hundreds, possibly thousands of testimonies from people who have had their lives changed through our speaking ministry. If you'd like that for your congregation or community, then use the link in the description and contact us today. So you mentioned igneous rocks and volcanic, or are they the same, or is it what sort of rocks are we finding there?
Okay, so igneous is a term. Igneous comes from, it's hot. Ignite, you ignite something, it's hot to form flame. So an igneous rock is a rock that was once molten. So it's a molten rock. And so that describes rocks which are underground, and they're typically called things like granite and other things like that, and they're termed igneous. But then when the lava comes out on the surface, it becomes volcanic rock, and it's given a different name. But it's basically all igneous rocks, which are hot rocks which have been melted.
Yeah, so when the meteorite hit, is it all igneous, or do you get some pressurized rocks? Or
well, it went down into the granite, and then the granite would melted, and that came back up. And the granite was already igneous; it had already been put into place there, and so this particular granite underneath the other sediments was impacted and came up and rebounded, like that drop of water coming out of the surface of that other area of water.
Thanks, that makes sense. And the other question I've got, I'm just thinking about picturing Noah's flood. And so you've got the water and you've also got Noah's Ark at the same time. And I mean, this is where I'm like, does that make sense to me? How do you think that would work, having Noah's Ark floating around and you got these meteorites, big ones coming down? Like, would that cause a tsunami wave? Would that affect the Ark, or like what's going on there?
Well, it would cause waves, and tsunami waves, they're very, very interesting tsunami waves, is that when you're in a big area of water like the ocean and you have a tsunami wave, which is caused by some movements in the Earth's crust, which causes a tsunami, the wave actually has got a very long wavelength and it doesn't have much height to it. And so a tsunami wave can pass underneath a boat and they'd hardly know that it passed if you're in the middle of the ocean. But when it gets near to the shore, that's when this long wave sort of builds up, it builds up and builds up, and it creates a very, very large wave on the shore. So the Noah's Ark was built in a very strong manner to be able to handle very, very rough seas. And also you'd have to think, well, the Bible talks a lot about how God brought the judgment on the earth. He brought the flood on the earth. He brought the animals to Noah. And it talks about a lot of things that God did. He remembered Noah when he was on the ark, and then he did this. So he was very actively involved in this. And so you'd have to think, okay, he must have been actively involved in preserving Noah so that no meteorites hit the ark directly. That would have been the end of it all. And so, that's what you might call providence in a way, so invoking the fact that God cared for and looked after his people, and that can be of a comfort to us in our lives as well.
Yeah, okay. So that makes more sense to me. A bit like when a tsunami comes, the big boats, they all go out to sea because they know the same wave isn't big and steep out to sea. It's in deeper water.
That's right.
It's more spread out. But we also have, it's clearly said in the Bible that God was looking up, took care of them. He designed the ark himself. And so we can assume that God really did look after them in a way too, maybe in some ways miraculous too. Yeah, well, that makes sense. Now, you mentioned another crater impact. Do you want to mention briefly about, is it Sudbury in Canada?
Sudbury. Well, maybe with the Vredefort, maybe I can talk about a couple of the ideas as to why they thought it was a impact crater.
Yeah,
some
sure.
of the things that featured with that. So some of the things were the fact that the size of it and the shape of it were some of them. But another one is that it melted a lot of the, there was a lot of the rock melted when the impact struck the area. And so this molten rock, it also fractured the granite. You can imagine it would have fractured it. So there'd be big cracks in it. There'd be big pieces of broken granite. And so you've got this molten lava, which is there as well. And so this molten lava fills in all the cracks. And the lava, turns out it was black. It was a black sort of granitic stuff. And it flowed around the pieces of granite and sort of welded them all together. And they give it a name. It's called pseudotachylite. It's a big name. I've learned how to say it. And there's a number of quarries in the area where they expose it, and you see the pink granite blocks surrounded by this dark magma, this dark basalt. And so that's one of the reasons why people thought that this is a impact structure. They find pseudotachylite in other areas where there are impacts. And so that's one of the reasons why they think it's a impact structure there. Another a reason why they think it's a impact structure is on the collars and that at the side, which are around forming these mountains. They are metamorphic rock, with their rock which has been changed by pressure. High pressure has made it very hard. And it also gets a structure in it that look like little fir trees, which is an interesting little structure within it. And these are also typical of impact structures in the other parts of the world. And so there's a number of things like this which have pointed geologists to think that this has to be an impact structure, which is why they've changed their mind.
So you see those similar types of features. Do you see the same ones at Sudbury as well? Or similar types?
Similar types of things in all sorts of different impact structures around the world.
Right. Fantastic. Well, there's another crater that I've been thinking about, and I can't remember the name of it, but I think there's one where they talk about dinosaur extinction.
Right.
They always say that this is all the dinosaurs went extinct because of one particular big meteorite. That wasn't the Vredefort one, was it? Or was it a different one?
No, it wasn't the Vredefort one. How do you say it? Chicxulub, something like that. That's the name of the crater. It's in the Yucatan Peninsula, which is around the Caribbean, in the south of the United States of America, Mexico, sort of in that area. So that was identified as a big impact structure there. And again, they're hard to identify. You sort of have to use maps and geological areas and look at it like that, and then put it together and surmise that that this was in fact a impact structure. Now, the interesting thing about this particular structure is it appears much later than the Vredefort one. Vredefort one was 2 billion years ago. This structure is claimed to be something like 70 million years ago, something of that order.
In that ballpark.
Ballpark. And so from a biblical point of view, the 2 billion is early in the flood. And the one which is about, 50, 60 million years ago, that sort of thing, would be as the floodwaters are reaching their peak. So that's about the area there. So, and it's about the place where, dinosaur fossils stop being found. Rocks which are a little bit sort of above that, you don't find dinosaur fossils in them. And the rocks there and a little bit lower, you find dinosaur fossils. So that's the interesting thing about dinosaurs when people started discovering them again in the 1800s and finding these fossils and giving them names. And it became very exciting, very interesting. People became engrossed by them, and they would put them on display in the museums, and people would like to see them. And they had not competitions, but there were various guys who were competing with each other to try to find the biggest dinosaur fossils, and they gave them different names like Tyrannosaurus Rex and that sort of thing. And so people became fascinated by these dinosaurs. And the thing is, you find them in the rocks. You find them in these layers of rock, and so because they believe in millions of years, they don't believe in Noah's flood. The people who found these and started talking about it, they called it the age of dinosaurs. And they sort of said, and eventually today they would say that is a period of about 200 million years. So it's the age of the dinosaurs, and the dinosaurs are incredibly successful evolutionarily, and they managed to dominate the planet, and they were the rulers of the planet, the age of dinosaurs. And then they went extinct. What happened? Why did they go extinct? Why did such a well-adapted creature go extinct? And so that's brought up all sorts of ways that people have tried to sort of work out. Okay, there's over 100 different theories for where they went extinct. And one is that there's the global warming theory. And then there's another one, the global cooling theory. And then another one is that dinosaurs were eating a certain sort of food, a certain sort of vegetation. And the vegetation became less fibrous. It evolved to be less fibrous. And so the dinosaurs died of constipation. That's one of them. Another one is they became, a certain vegetation evolved certain chemicals which became narcotic and addictive. Dinosaurs went out to that. Or there are animals which started to eat dinosaur eggs. And it just goes on. There's over 100 of them. And, even some of the comic strips have got these amazing cartoons of why the dinosaurs went extinct. And I've seen one, Far Side, where you got these dinosaurs standing around smoking these cigarettes, and why the dinosaurs went extinct. But what's happened is in the recent years, this asteroid impact has just captured everybody's imagination, and they all think, that's it. And it makes good movies. There's a lot of movies about asteroids, and a lot of the discussion of dinosaurs talks about this asteroid impact. And so the idea is there's this asteroid that hit the Earth. It blasted all this dust into space, into the upper atmosphere, and it caused a really cold weather on the Earth because it kept out the sunlight, and all these animals couldn't survive in the cold, and so they went extinct. So that's generally the idea about the dinosaurs, why they went extinct. And as I say, there's actually a lot of secular geologists that don't believe it, and they think it's wrong, and it's got a lot of evidence against it. And so it's very popular. I don't know if the scientists are going to be able to overturn the popularity of it, but that's where it is at the moment.
Yes, it's obviously quite a difficult, particularly from the secular, ignoring the global flood. It's quite a difficult thing to explain how all the dinosaurs, just in a certain very distinct way in time, in their timeline, all went extinct at the same time. So what are some of it sounds like you're saying, the Chicxulub crater, that, the asteroid impact sounds the most sensible option at the time, almost widely held belief at the time. At the moment, what are some of the problems with this that you see?
Well, these ideas, they've got a life of their own, and it all depends upon if the media pick them up and how they portray them and how people like them and the books that are presented. And so they, there's various fads. And so this is like that, I think it's like that. So there's this layer that is associated with meteorite impacts, this iridium layer. And so the idea is they saw this impact. Here's the impact structure. This is where the structure is. And look, and they saw these iridium layers in lots of different places on the Earth. And it occurred just at the time when the people said the dinosaurs went extinct, which used to be called the KT. K is the Cretaceous and the T is the tertiary layer. So at that boundary is where the dinosaurs supposedly went extinct. Now they've renamed parts of the geologic column and it's called the KPG, which doesn't sound as good as KT, don't think. Anyway, so that's where they're supposed to go extinct. So how do you know which rocks belong into the KT, into the underneath? What rocks are dinosaur rocks? Well, they're rocks which have got dinosaur fossils in them. So it doesn't matter where you find them. If they've got dinosaur fossils in them, they're below the KT boundary. And so it's a sort of a circular argument, isn't it? Because if you find them in layers of rock above the boundary, then obviously that actually should be below the boundary. And so it's a sort of self-serving way of organising it. And so that's the way that they've sort of said it's perfect. That's what describes it. But actually, the impact occurred at a different time from the KT boundary.
Right.
And so there's a problem there. This iridium layer, it's not nice and neat all around the world. There's 100 different iridium anomalies where it's occurring where it shouldn't. Which isn't surprising if indeed there were multiple impacts on the Earth occurring during the flood. You would expect iridium to be in different places, not all at the one level like that. And so the idea that this meteorite impact caused the dinosaurs to go extinct, it's got a lot of problems with it. Another problem is if it caused this great big cooling on the Earth due to the dust around, what's going to happen to all the plants that need photosynthesis? The plants aren't going to survive. And if the plants aren't going to survive, then there's going to be the animals that live on the plants aren't going to survive. And then you've got the birds. How come birds survived? Whereas they are a lot more sensitive to this sorts of things than other animals. Like you talk about the canary in the coal mine. And so the canary's there because it's certainly sensitive to this thing and it gives an early warning. So the whole idea of this big meteorite impact causing the extinction of the dinosaurs has got a lot of problems on it. Now another one, I'm doing a lot of talking here, but you did ask the question. So what happened to the dinosaurs? We're told that the dinosaurs have gone extinct. That's the question. What happened to them? But in actual fact, we talked about them being found in certain layers of rock and not afterwards. But dinosaurs would have gone on the ark, Noah's Ark. And so dinosaurs would have gone on because he was told to take 2 of every kind of air-breathing, land-dwelling animal on the ark. So there would have been dinosaurs. And you don't need, you've got lots of different types of dinosaurs. You've got, for example, you've got the Triceratops. There's lots of different varieties of Triceratops, but you'd only need to take 2 of those on. And then the sort of the other sauropods, 2 of that kind. So maybe 50 sorts of dinosaurs went on the Noah's Ark, and they would have come off the ark. So they would have survived. And people would have seen them, just like you've seen elephants and tigers and lions. They would have been familiar with dinosaurs. But they called them a different name. They called them dragons. When people discovered dinosaur bones, the people who did the checking of the bones and exploring of the bones and the naming of the bones, they used to call them dragons. And it was a guy in the museum looking after the British Museum who called them dinosaurs. What am I going to call them? They look like terrible lizards. We'll call them terrible lizards. Dinosaur, terrible lizards. And so there's a lot of stories about people encountering dragons. And I think you can make a good case that dragons are dinosaurs in history. So they're actually dinosaurs. And so there's an example of dinosaur etchings on a Carlisle Cathedral in England.
Yeah.
You can see amazing there. And there's actually countries all around the world have got representations of dragons, and they can be identified as dinosaurs. So did a meteorite kill the dinosaurs? No, it didn't. They survived Noah's flood, and they lived well after the flood. Why did they go extinct? I don't really know. I've got a friend that reckons they went extinct after the shotgun and gunpowder was invented, but I don't know about that. But they were hunted. You heard of St. George and the dragon. The dinosaurs created problems for communities, and so they hunted them. And lots of animals have gone extinct, in the last 100, 200 years, lots of animals. And so if you think of dinosaurs like any other animal, it's not that surprising that they've gone extinct, but it wasn't the meteorite.
And there would have only been a few coming off the ark. So if they did get hunted early on, that's it.
That's it.
Those ones are gone. So there's a few ways. So just to summarize a little bit, so we're looking at, the flood wiped out a lot of dinosaurs. There were some on the ark, but a lot of them were wiped out. And that's what we see in the fossil layers today.
All the ones that didn't get on the ark.
That's right. So but we've got other creatures as well. And I know this is a point, I often hear these questions where people say, okay, you've got all these dinosaur bones and there seems to be this order in the fossil record. And, where are all the mammals in the, with the dinosaur bones as well? But I was just thinking that's actually, I know you can go to creation.com, they got some articles to explain that, like there's different buoyancies and habitats and quite a few different explanations. But that problem's actually seems to be more of a problem for the crater impact idea, because they suggested that there were mammals living around at that time, but somehow the mammals all happened to survive just by digging holes and things like that to survive a big meteorite, impact.
So that creates a problem as to why did it kill the dinosaurs and not all these other things?
Yeah, it seems like actually quite a significant problem for the secularists, not just a one-sided issue.
But it's a good story, but like all fads, it eventually will run its course, and there'll be a change of thinking.
Well, thanks for sharing. I've learned a lot about meteorites today. Things that I'll, when I hear these stories about dinosaur extinction, I'll have, now I understand, what actually did happen with Noah's flood and meteorites during Noah's flood too. I think that's very interesting. So can you just quickly summarize, just the story of it in a quick way, summarize what Noah's flood would have happened, how the meteorites, got there? Tell us, paint a picture for us.
Well, it seems like meteorites were a part of the catastrophe of Noah's flood. Some people think that they might have started the flood, but where the Vredefort crater occurred, there was a lot of flood deposits already formed at that time. But certainly we see the meteorite impacts on the moon, which gives us an indication that there has been a cosmic catastrophe and it has affected the Earth. We see the impacts on the Earth. And I think that's interesting that it warns us or reminds us that we live in a place where we are vulnerable on the Earth, and it's not set in stone, so to be, but and the Bible reminds us that there's going to come a time when the whole Earth is going to be destroyed in fire. And I don't know when that's going to be. Hopefully it's going to be a long way away. But it does remind us that we live in a planet which we sit on the edge of a knife. Did you know that governments actually have got policies in place to try to, if they detect an asteroid, a meteor that's headed towards the Earth, and as they calculate it out its trajectory, if it looks like it's going to impact the Earth, then they've got policies in place. So they're going to send a rocket up to the meteorite and they're going to deflect it so that it misses the Earth. So the governments are taking these sorts of things seriously. But I think it indicates, the meteorites and that sort of thing indicates something of the judgment of God to me, and also of the preservation and the fact that he provided a a way for people to escape the judgment in the midst of it. And that's why we're here today, because we're descended from Noah and all the people that were with him on the ark.
Well, that's a great summary, Tas. Thanks for sharing. It sounds like the global flood truly was an apocalypse on Earth. Now, I'm sure our viewers have got a lot of questions, and hopefully some of those are answered to do with meteorites today. But there's so many other questions out there about astronomy, about biology, all types of evolution. And we're actually giving away a free book today called the Creation Answers Book, which answers so many of these common questions, and it gives really nice, easy to understand answers. So can you tell us a little bit about this book, Tas, and why it could be useful for our listeners?
I can. I think there may be people watching this little presentation who might think, that is crazy. The first time you hear about this idea of Noah's flood and meteorites and all that sort of thing and a young Earth, and for many people, it's just a bridge too far. But for many people, it's a stimulus. It's like the thing that sets them on a journey where they start to do more research and more reading. And that's why this is a good book. The Answers book is a great book. And a lot of people find that it covers a lot of topics. It covers things like creation, talks about fossils, Noah's flood. It talks about the order of the fossils. It talks about how animals survived. And the dinosaurs, there's an article in there about dinosaurs and cosmology. There's articles, 61 different topics, questions are dealt with in this book, the Creation Answers book. And I know lots of people who have been greatly helped by that.
Excellent. We'd like to give you the Creation Answers book as an ebook for free. So just check out the description below, and there's a link in there where you can find it. Thanks for joining us, Tas. It was great to learn about meteorites.
Good on you. That's been excellent.